Hi, my name is Indigo. I go to City Arts and Tech High School. It's a charter school here in the city. I just finished my junior year, going into my last year. And I did 3 projects. My first project was a starter project. It is a portable phone charger that charges on AA batteries, like his was. But I made a modification to it to where it had a little solar cell on top of it, so if it was in the sun, it would recharge the AA batteries that were inside, charging your phone. So the gist of that was just I had a little circuit board that I just soldered everything to. It was a kit, had all the instructions, it didn't take a lot. It was just for me to learn how to solder. And with the solar panel, I attached it through it had a little switch, so I could switch when the power was going from the solar cell to the batteries. Unfortunately, I don't have it to show you. It's all in shambles in a box, but I could get that back together pretty quickly. Then the main project that I did first was an RC tank that was controlled with a PlayStation 2 wireless controller. So what I did was, to start, I had to hook up the PlayStation 2 controller to the Arduino. What I did is I took the wireless chip receiver that it came with and I just sawed it open to where all I saw was a circuit board. And I got some jumper wires, soldered them on there, and just put them on pins in the Arduino. And then when I wrote my code, I distinguished in the code what each pin did. So when I control it, receives the controller and turns it on and makes it go. When I control it, and it wasn't working really, I just got it to work during the middle of all this. So I press a button, it just rotates, goes there, has a break. Initially when I tried to write it, I made it so that when you press the button, as it's pressing the button, it goes, but it wasn't working, so I changed it so you just tap the button, and it does the command until you do something else, one of them being the brake, obviously when I felt like I didn't want it to move anymore. And this came with a lot of problems, like what he had with his PS2 controllers. Some days I'd come in and it would just work right off the bat, and it let me do what I wanted to, and other days I would turn it on and it would not connect, and that was just right now too. So it's iffy, but when it works fantastically. Other problems I had were wiring. Most of it is just like you figure it out in forums on the internet where other people try to explain how they did it. They don't explain it very well, so it's a lot of going out on your own and learning the fundamentals of it. And another thing, I had to learn the code from scratch because the original site where the project came from, it had a code, but it was for a different motor shield. It was just a completely different company, used a different set of code. So I had to learn the specific code for that, write it all from scratch, which, I mean, it taught me a lot, but it was a lot to learn all at once. I managed to get it all together. And yeah, so that's my thing. And for my third project, which I haven't completed yet, all I have here is a circuit, and this is a bicycle power generator. It's another generator way to charge your phone. And what it is this is a dynamo, which is the opposite of a motor. So with a motor, you put current in and it spins. With this, it spins and then you generate current. So you have this hooked up to your bike, it's mounted on the frame, and when the wheel spins, this will spin, generating power. And I have it run through this circuit, and what the circuit does is it regulates the power, because in phones and applications and all the things that you do, it requires a direct current, but this generates an alternating current, so it waves a lot. So direct current just sends current through, alternating current on, off, on, off, on, off really quickly. So what this current does, or the circuit does, is it changes the current to be direct so that it will charge your phone. And what this behemoth of a piece does is when the current goes down, this holds power, so it will just send it through your phone constantly. And while this generates it, this holds it all, it sends it straight to your phone, keeps it charging. And how I have it hooked up from the generator to this, ideally, is it's going to be EL wire, which glows. So while I'm pedaling, it'll generate power, which also have really cool glowing wires on my frame. So I just have like this awesome looking bike at night that's just glowing, and it's also charging my phone. Practical angle, which is how yes.
How much power can your generator create?
It's labeled to generate 12 volts at 6 watts, but when I actually tested it, it generated closer to 18 volts, so a little more than I anticipated, but it was easy enough to corral. and it lit up my LED, which is what I tested it with, but I haven't tested it with the phone yet because I only just got the circuit completed today.
What's the charge requirements for the phone battery?
The phone battery requires 5 volts of DC, so this generates 12 to 18, depending on how quickly I'm spinning.
The power, not the, how many watts?
Not sure.
So
Somewhere.
but my point is you match the generator size to the need.
Yeah. It matched it in wattage with that, yeah, in my circuit.
Because it seems like the generator is way too big.
The current isn't that high. It's the voltage that's a little bit higher, but the current is manageable. It's only 6 watts. Any other questions? Yes?
There seem to be a lot of, you mentioned the fact again that you have this thing on and sometimes it works and sometimes it doesn't, which doesn't seem to be unusual in this class. These it seems to be kind of symptomatic of having the power circuit going on and leaking noise over to the computer circuit. And normally, I guess the shield is something that's supposed to go on and look for that. Have you guys actually hooked a scope up to the power line and see what it looks like going into the Arduino?
I did, and the powers seemed to be pretty consistent, so I wasn't sure what it was. I was testing all the pins on a daily. The pins just had a power that it was listed at going in. It was just something between the motor shield and the controller that wasn't coming together at times. But usually if you press the reset button enough, turn it off, turn it back on, it'll work.
Well, it works for pacemakers.
Hopefully that one's not turning on.